Hello, all. This is Radhika from Pantechelearning. Very good evening, everyone. Good evening, all. Welcome to 21 Days Masterclass series on electric vehicle design. Today is day 5. Very good evening, all. Yeah. I hope you're all doing well and had a productive day. I hope I'm audible right now. Okay. I welcome you all for engage your learning experience with Pantech Learning anytime, anywhere, at any places. We are always supporting to the students in a technical way, and our main vision to help 10 million students easily learn the technology. So today we are going to talk about one interesting topic, that is a PWM controlled DC motor. So PWM is nothing but pulse width modulation. So first of all, in our simulation, we have a special type of motor that is known as a DC motor. So this motor is like the powerhouse behind many machines we use every day, from our fans to our electric cars. So we are going to explore how changing the PWM signal that affects the speed of this motor. So first of all, I will tell you what is this PWM. So PWM is nothing but pulse width modulation, as I said earlier. So this is one kind of the method that is used to control the average power that is delivered to the device. So before we get into the topic, so this is our final project. Already we have learned how to model this vehicle body. So inside this vehicle body, we have a tires and also the physical model of vehicle body. So this thing we already learned. So next we move on to the motor controller part. So inside this motor controller part, we have this DC motor PWM control method. And this is the simulation model. So here we are using PWM method that is used to control these power, the average power delivered to the device, such as a motor or a light. So you can vary the width of the pulses in a some periodic signal, some in a time period signal. So in a simple terms, it's like adjusting the brightness of a light bulb. So by flicking the switch on and off very quickly. So how does this PWM work? So imagine you have a light switch. So when you turn it on, the light shines brightly. When you turn it off, the light goes out. So instead of just leaving it on or off, so you start flicking the switch on off really fast. So the time the switch is on compared to the time it's off means that determines how the bright the light appears. So the same idea applies here. In PWM also, we send a series of quick pulses of electricity to our device, which may be any device, a motor, light, like that. So the width or a duration of each pulse that determines how much power is delivered. So a wider pulse means more power, while a narrower pulse means we get less power. So this is the PWM work. How does PWM work? So why we use this control method? Why we use this PWM method to control the speed of a motor? So basically this PWM, it allows a precise control over the power delivered to the device. So you can adjusting the width of the pulses. You can adjust the pulse width. We can control the speed of the motors. So because this method is efficient, because it's like turning the power on and off rapidly. So this means we can control the power without dissipating excess energy as a heat form. We can save energy, which can save energy, and also it reduces the cost. That is why we are using this method. So we are controlling the speed of a car with PWM. So if you want to car to go fast in the sense, you can send longer pulses of the electricity. So if you want to slow down in the sense, you can send the shorter pulses. So you can adjust the pulse width. You can make the car go at just right the speed you want. Because this PWM is a one kind of a clever method. So that is still let us control power by rapidly turning it on and off. So it can be used in many devices around us. So because it is a very essential for this modern electronics and also the engineering. So let us get into the simulation, MATLAB simulation. I will show you the simulation also. So this is the DC motor speed control. So PWM control DC motor model. So first of all, we are using this solver configuration block. So why we using this solver configuration block? Because this solver configuration, it defines how our simulation updates, how our simulation calculates the behavior of the system over the time. So this entire simulation, it can be considered as a one equation. So we can solve equation by using this solver configuration. So that is why we get the better results. That is why we need the solver configuration block. So next we have a converter blocks. That means PS to Simulink converter. Basically, this PS to Simulink converter is nothing but PS is nothing but physical signal. So this block, it converts the physical signals, it's like a voltage or a current in a real world system, into a signals so that Simulink or simulation can understand. So basically, it bridges the gap between the physical world and also the digital world of our simulation. So next we have a controlled PWM voltage block. So what is this block? So basically this controlled PWM voltage block, it generates a signal. It's like a pulse width modulated input for our motor. So this PWM method where we rapidly switch a signal on and off to control the power delivered. So this block, it creates the signal to control the motor speed. So next we have a Hutch bridge. So what is the use of this Hutch bridge here? So basically this Hutch bridge is an one kind of the circuit that allows to control the direction of current flow through the motor. So this Hutch bridge, it enables us to make the motor spin in a both forward and also the reverse directions by switching the polarity of the voltage applied to it. So this block, it controls the Hutch bridge to change the motor's direction. So next we have a DC motor. So we know the DC motor block, it represents the physical DC motor in our system. So it converts the electrical energy into a mechanical motion. So this block, it captures the motor's behavior. So including its torque speed characteristics or any response to any voltage inputs like that. So next we have a current sensor. So by using this current sensor block, we can measure the current flow through the motor. So it converts this current into the measurable physical signal. So that allows monitor how much electricity the motor is using. So this information is a very crucial for understanding the motor's performance and also efficiency. So next we have a DC voltage source. So this DC voltage source, this block, it represents the power source. This is the entire power source that's applying a voltage to our system. Basically, this one, it generates a constant DC voltage. So that's simulating a battery or a power supply. So we can adjust the voltage level to control the power input to the motor. So next we have an important block, that is the electrical reference block. So why we use this block? Basically, this block, it one kind of the reference point for the voltage in our system. Electrical potential is nothing but an electrical potential for our system. So it's nothing but a ground. It's like a ground. So for measuring and analyzing the electrical signals within the simulation model. So next we have a mechanical rotational reference block. So this block is also the one kind of the reference block that defines a reference point for measuring the rotational motion in our system. So next we have a ideal rotational motion sensor. So this one is the ideal rotational motion sensor. So this block, it acts as a sensor to measure the rotational motion of the motor shaft. So it converts the mechanical motion into a measurable signal. So such as the angular velocity or angular position. So this information, it helps us to analyze and control the motor's behavior. So finally we have scope block. So do you have any doubt in this? So this is the entire model. So before I am going to run the simulation, do you have any doubt means please mention in the chat box. So basically this control PWM voltage, it generates a PWM signal. That means it generates a sequence of pulses. So this block, it creates a switching pattern for our motor. So when the signal is on, the output voltage is equal to some specified amplitude. It's like a plus 5 volt. When off in the sense, that means low. The output voltage is 0. So here we have a duty cycle. So duty cycle is nothing but on time to the total period. So which is the ratio of on time to the total period of the PWM signal. So it determines the average output voltage also. Because this double click on this PWM voltage block, here you can see the modeling options and also the simulation mode. So this block is also has a simulation mode option. Because PWM mode in the sense it output is PWM. Average mode in the sense it output is a constant voltage that is equivalent to the average of the PWM signal. You can change this one also. So next we have a Hutch bridge motor block. So as I said earlier, this block is one kind of the circuit that is used to drive a DC motor. So both this DC motor we can rotate in both forward and backward. That means reverse directions also. So this Hutch bridge only, it receives the control signals from this PWM block. It decides how to apply voltage to the motor. Here we have a lot of ports. One is PWM port, another one is reference port, another one is reverse port, another one is braking port. So PWM port, it receives the PWM signal to control the motor speed. REV port is nothing but a reverse port. So it determines the motor's direction. So when the voltage exceeds a certain threshold value, the motor spins in a reverse mode. So next, braking mode, it activates the braking mechanism. When the voltage here exceeds the threshold voltage in the sense, it initiates the braking action to stop or to slow down the motor. So next one, a reference port. So it provides a common reference point for our voltage measurements within that block. So by short circuiting this port, we can establish the common ground for a voltage calculation. So that is why we done that one. So do you have any doubt in this? So here we have a DC motor. So we know the DC motor, this block, it generates. So this DC motor speed is controlled by the PWM. So here we have a reference voltage. That means PWM reference voltage. Here you can see our reference will connect it to this DC voltage source. So this block, it generates a constant voltage signal which acts as a reference for controlling the motor speed. So think of it like the gas pedal in a car. So the voltage, it determines how much power is sent to the motor. So this is the DC voltage source. So here I am going to give the value here. Here I am going to set the constant DC voltage is 2.5. So we are setting the constant voltage to 2.5. This is a baseline power. This is the baseline power level for the motor. So for the controlled PWM voltage block, so we are setting the frequency also. So we are setting the frequency to 4000 Hz. So this controls how quickly the signal switches on and off. So we are setting the simulation mode to average. Or if you want, in the sense, you can change this one also. So I am going to set the average mode. So which means we are approximating the PWM signal by considering only its average value. So this helps speed up your simulation. So it's still getting a good estimate of how the motor behaves. So double click on this Hutch bridge. So Hutch bridge also you can see the simulation mode. So in average mode, in the sense, the block will simulate the motor's behavior based on the average value of the PM signal. So it approximates the motor response to that PWM signal, that means sequences of pulses, by considering its average effect. So in PWM mode, this block will directly interrupt the PWM signal received from the controlled PWM voltage block. So it will apply the PWM signal to control the power delivered to the motor. So the main difference here, it lies between the signals. That means in average mode and also the PWM mode. So average mode, the block consider the average effect of that PWM signal. So it's simplifying the simulation for the faster results. In PWM mode, in the sense that this block it directly use a PWM signal, providing a more detailed and accurate representation of the motor's response to that PWM control. So next we have a DC motor. So this DC motor, double click on this DC motor, you can see the parameters inside. So we can choose our field type and also we can model the parameterization. So that means by rated load and speed. So this setting, that means the motor's behavior is parameterized based on its rated load and also the speed. Here the armature inductance value is 0.01 and this is the inductance of the motor's armature, and no load speed, the speed of the motor when there is no mechanical load applied in the sense, that is a 4000. So the rated speed it should be 2500. The rated power it should be 10 watt. That is a mechanical output power of the motor. When operating it's a rated load and also the speed. So the rated DC supply voltage is 12 volt. So then go to the mechanical section. So this is the mechanical section 0.002 kg meter square. So this is the inertia of the motor's rotor. So next we have to set the rotor damping value. So this one it affects its ability to resist changes in the speed. So that is the rotor damping. So before I am going to run this simulation, I will give you the internship details also. Just a minute. So this is the live class versus internship benefits. You will get free session by this live class and also the demo, and you have an idea, you got an idea about that topic, and you will get 21 days free session only on this live class. But if you are an internship user, you will get the recorded session and also you will get complete simulation model, how to build this model and how to take the blocks from that library like that. So and also you will have a mentor support, and you will weekly you will have a hackathon session, that means doubt clarification sessions, and you will get 9 days additional record. So you will get 30 days of recorded content for this internship users. So the actual price is 1,999 and we are giving the 799 plus 18% GST. So use this registration link to join as an internship user, because this offer will be closed on 7/6/2024. So this offer will be only for a limited period one. So what are the benefits you will get in this internship? In essence, you will get 30 days of live sessions and 90 days of recorded content, and you will get 10 plus simulation files related to the electric vehicle design projects and 30 downloadable presentation, and you will get the e-certificate. And also you will get 5 to 6 projects from this electric vehicle design. So the project 2 is a battery pack. So how to create a battery pack for an electric vehicle, or how to create a battery pack for a EV two-wheeler or four-wheeler like that. So this is the procedure. So first you have to create a cell, and after that you have to create a parallel assembly, and then you have to create a module, and finally you have to create a module assembly, and then finally you have to create battery pack for your electric vehicle. And this is the output of our simulation, and this one is a project 2. So the project 3 is cell balancing. So we have to know the cell balancing, and we have to do the cell balancing, because inside the battery pack we have a lots of cell connected in a series or a parallel form. So we have to balance all the cells inside the battery pack for improving the efficiency of our electric vehicle. So this one is a active cell balancing. There are 2 types of cell balancing methods available. One is passive cell balancing, another one is active cell balancing. So this project's simulation is an active cell balancing. So this is a project 3. And this one is a project 4. So how to create a simple battery pack. That means 3S 2P battery pack. That means 3 cells in a series and 2 in a parallel manner. In a simulation. So how to create 3S 2P battery pack in simulation? This is a project 4. So these are the projects you will get through this internship. And also you will get additional 9 days record. So not only DC motor speed control. So today our simulation is DC motor speed control. That means PWM control method we are using. And additionally, you will get BLDC motor and AC induction motor and also the PMSM motor and SRM motor. Only for the internship users. You will get simulation files also. And next you will have the additional 9 days of recorded content for internship user. So the actual price is 1,999 and we are offering 799 only for the limited period. So don't miss out this opportunity because this one is a very reasonable price. So use this registration link to join as an internship user. How to do the payment? So first you have to fill your name and you have to type your mail ID and you have to put your mobile number and you have to put your department and also organization. So this is the payment. And next one, we are offering exclusive 3-in-1 offer, 3-in-1 bundle. So this 3-in-1 bundle consists of the 3 big master classes. One is EV design, another one is MATLAB Simulink. So EV design for 30 days and MATLAB Simulink for 30 days. That means 30 hours recorded content. And PCB design you will get 10 to 12 hours up to the double layer. So first you will have the single layer and after that you will go into the double layer. So up to double layer you will get the record. That means 10 to 12 hours. So we are offering 3-in-1 bundle. So this offer also will be closed on 7/6/2024. This offer also is only for the limited time period. The actual price is 2,999. We are giving the discounted fees is just 1,299. So 1,299 plus 18% GST. So use this registration link to join as an internship user because this offer will be closed on 7/6/2024. This is the last date. So listen carefully. This is the last date. So don't miss out this offer. Don't miss out this exciting benefits. So what are the benefits? You will get this bundle, 90 days of recorded content and 1 year validity. Guys, 1 year validity of recorded content and you will have 20 plus simulation files related to the electric vehicle design and also MATLAB Simulink design. So in a MATLAB Simulink masterclass, you will get the basic power electronics based topics. How to create a simple system, how to create a converter, buck converter like that. And also you will get 90 days downloadable presentation and internship confirmation letter and internship certification. So now I am going to run this simulation model. So just run this simulation model. Let's see the output. So this DC motor, the data sheet of the DC motor, it delivers the 10 watt of power at a rated speed of 2500. But it is powered by 12 volt DC supply. So additionally, it mentioned no load speed is 4000. Okay, no load speed is 4000 RPM. So let's see the output of this one RPM. Just a minute. So here you have to change this to PWM mode. Now you have to run the simulation. So this controlled PWM voltage block, it generates, as I said earlier, this PWM signal, it switches on and off rapidly. So that controlling the average voltage that applied to the motor. So when the PWM reference voltage is set to the maximum value in the sense, I will show you the output. Yeah, so our speed is reduced because our no load speed, what is our no load speed? Maximum speed 4000. So here we are using this method, our speed is reduced. So just a minute. So what is our PWM reference voltage? Here the input voltage for a 100% duty cycle is 5 volt. So that means when the PWM reference voltage is set to the maximum value of the plus 5, the motor runs at maximum speed of a 4000 RPM. So this is because the maximum voltage results in a maximum power that is being delivered to the motor. So here what is our reference voltage? So the constant reference voltage is 2.5. So which is half of the maximum. So which is half of the maximum. So the motor runs at approximately half of its maximum speed only. So that is why we are getting the 2000. So the maximum speed is, actual maximum speed is 4000 for a maximum reference value plus 5 volt. So if you are reducing the voltage to 2.5, that means which is half of the 5 volt. 2.5 in the sense, the motor runs at a half of its maximum speed, it's around 2000 RPM. So this reduction in voltage that reduces the power delivered to the motor. So that causing to operate at lower speed. So this is the way you are going to control your speed by using this method. So do you have any doubt in this? So this is the impact of the duty cycle of this PWM signal because it basically this PWM signal, it determines average voltage applied to the motor. Higher duty cycle means it generates lead to the higher average current drawn by the motor to maintain the desired speed against that load. So based on the duty cycle only, when the duty cycle is increased, that means resulting in a higher average voltage, the motor speed tends to increase. Conversely, if you decrease in the duty cycle, it lowers the speed. So this is the way you are going to control your speed of your DC motor in your electric vehicle. So this is all about today's session. Do you have any doubt means please mention in the chat box. So again I will tell you the internship offer. So this one is, if you want only the electric vehicle design masterclass, use this registration link. The actual price is 1,999. We are offering 799 plus 18% GST. Or else you want only bundle in the sense. This is the registration link and actual price is 2,999 and we are offering 1,299 plus 18% GST. So use this registration link to join as an internship user. So this offer will be closed on 7/6/2024. So if you are an internship user, you will get lot of benefits. You will get projects and you will get hackathon sessions and you will get mentor support and you will get the hands-on experience also. So thank you so much. Thanks to everyone who joined today's session. Thank you all.